Hello guys, so today we'll be talking about the development and deployment of smart contract on the testnet. So I would be talking about how we can deploy a smart contract. So let's get started. So initially, we discussed about the smart contract and the features which are it manages the state and data. It has got code and functions, and it has got a unique public address, and then we can read and write data via functions, and we can use these languages, and there are several languages, but we'll be using Solidity. So let's get started. So I would be opening the screen where I've got this Remix environment open, and this is basically the IDE which is online. It can be accessed via remix.ethereum.org. It's IDE for Ethereum, and which is a blockchain. And in this we will be coding in Solidity programming language. So if we want to deploy it on the testnet, so we need to have our wallet configured. In this case, we would be using MetaMask as a wallet for testnet. So let's get started, and then we would move on and discuss further. So at this presently, you can see that it has got this starting point. So initially in a smart contract, so you can see that I have selected hello world.sol. So this is the extension, which is a Solidity file. And then the first line is this, that it's an identifier of the license, which is MIT. And then we start with choosing the compiler. That's Solidity's compiler. We will be using 0.8.10, and then this is the contract, hello world. All right, and now let's look at constituents. So this is a string, a simple string, which is kind of a greeting, hello smart contract. And then here we've got a function which is callable, which is readable because its name is GetGreetings and it's public, and we have mentioned view here, so it's readable and it's public. So this is a very simple smart contract, and whenever we would call this function GetGreetings, we should get this greet variable, whose value is this. And we can also, since this is public variable, so we can always access this greet directly, but for the sake of simplicity and just showing the functionality, so we have got a function here, and this is greet. So after writing the code, we need to do first compile the code. All right, so we would go to the Solidity compiler, and we have chosen 0.810 as a compiler here, since we have mentioned this here. And let's compile it. Okay, so it's compiled, and you can see this green tick mark. Now let's deploy. So note that we will be deploying on the testnet. I'll be showing you. So let's deploy. So here it's the details I mentioned. So here I have chosen injected web3. So now, since we are planning for the testnet, right? So injected web3, and from here we need to choose our hello world smart contract. So whatever the name is here, we need to choose that from this drop down, and then we need to press deploy. So what would happen when we would press deploy? We would be prompted with a MetaMask, which is a wallet, and then we need to approve this transaction. So now we are ready to deploy. So let's hit deploy, and as expected, we will be prompted with the MetaMask, and this shows that we have Rinkeby test network activated in the MetaMask, and the estimated gas fees is 0.00514 Ethereum, and it keeps on changing, after every 15 or so seconds. And the point is that whatever a write operation is needed on the chain, it requires some gas fees. Gas fees is basically the Ethereum which the chain charges. So let's confirm that. And now this transaction is on Etherscan. It's pending. So now we've got the confirmation also. So now it's being indexed, and Now it's successful also. So here we can see, in this console that, our transaction. So now it's succeeded. Now we can interact with this smart contract. So we do know that, we have got this GetGreetings function. So in this IDE in the Remix, we have got this interface. What we can do is we can also get the value of greet, which is a variable, and then we could call that this GetGreetings function. So let's call this. So you can see it fetches from the chain hello smart contract, and we are interacting with this contract which has this address EC7 onwards, and you can see this that this is a EC7 something. So this transaction, basically this shows that whenever we hit deploy, so we do get this transaction hash. So this is a transaction hash as mentioned here on the Rinkeby test network. As you can see, this is the Etherscan of the Rinkeby network, and in this transaction we can see that a contract was created. So here we can see a contract is created. So this transaction is basically a unique hash for identification of what happened on the chain, and this is a unique address of the smart contract which we are interacting with here. So Remix ID gives us this interface from where we can interact with our smart contract like we did. We called this GetGreetings function, which is here, and we got the output hello smart contract, which was expected because the greet was returned, and greet has this value of hello smart contract. In the next contract we will be changing its value. For this, what we have done is we have also, since we were testing on Rinkeby test network, so we have chosen this inject web3. So yeah, so this cycle is complete. So now let's go to another contract, which is GetSetGreetings. So in this we would be not just getting this like previously we had just hello smart contract hard-coded variable and we can't do anything but just read. So in this smart contract we would be first setting the greeting variable, and then we would read this variable. All right, so let's see what is this. Again, this is the first line. So again, the get set greetings.sol, it's a Solidity file, and this is again remix, and the first line indicates that the license, and then this line indicates which compiler we are planning to use, and then from here the contract starts. The name is greeter, and this is the constructor, and these are the two functions. This one function is the view function, which is to read whatever the greeting value is, and this is the set greeting function, which we would pass some value in it, and then that value will be stored in the greeting variable. So in this way, we can also, like I said, that we can read and write on the chain. So via the smart contract, which is basically a set of functions, we can do that. All right. So first of all, we need to compile this. So let's go ahead and compile GetSetGreetings, and we have got a green tick mark, which means it has compiled without any errors. And so now let's clear the previous one, and from here we need to choose the greeter contract. We are good to go. We have chosen injected web3 here from all these options, which means that we are opting for the MetaMask wallet to prompt, and the test network would be Rinkeby. So let's deploy this. So we can see that this is again the gas fees required for deployment. Let's confirm this. So now we have got a transaction on the Etherscan, and it's pending, but we have got a transaction hash to monitor this transaction. So you can see this transaction hash here, and now it's confirmed, so it will be indexing right now. So after refresh, we can see it's indexing, and we can also see the state here also on this remix console. And let's see if the process has succeeded. Okay, so we have got this deployed, and yeah, so this is deployed contract, and its address is, it starts from 0 to 9, ends with E41. See, so this is the contract 0 to 9 E41. So this was the transaction hash in which this contract was created. So we can also click on this contract. Let's see. So this page shows this contract and all the transactions which we would be doing here, it will be shown below this. So let's see the functions. So yeah, as expected, we have got setGreeting, which is this function. We need to pass some value. So you can see we have got this underscore greeting we need to pass. We have mentioned it here. Let's pass, this is a smart contract. All right. So now one more thing, that any write operation would prompt MetaMask, because every write operation requires gas fees. So of course there are several checks and functions and modifiers we can apply on the function, so that not everybody and anybody can write the smart contracts, but that would come later. For now, let's confirm this. So I have this confirm button, and I've pressed the confirm button, and again the transaction can be viewed when this transaction will be successful. So we'll be able to call the getGreeting function. So we have got this confirmation. Yeah, so now it's indexing. Of course we are on the Etherscan. So now it's success. So now if we call this greet function from here, so it's expected that we would get this is a smart contract. So let's do that. The read function doesn't require any gas fees, so we won't be prompted with a MetaMask. So this is what we've got. This is a smart contract, which has proven and shown that we have called this function and then we got this value. So now change this to hello. Let's do transaction. Again, since it's the write operation, MetaMask is prompted, some gas fees would be charged. Let's confirm it. A transaction hash is given. Like I said, each and every transaction, each and every write operation has got a transaction. This transaction is pending. We've got the confirmation. So now it would be indexing. Let's see. So yeah, it's indexing right now, and we can see this, our smart contract, and the transaction should show. So this is a previous transaction which was setGreeting. Let's see if it, okay, so now this is all successful. So previously when we pressed the greet button, we got this is a smart contract, but since now we have passed hello in the setGreeting, so after calling this greet function, we should get hello. So let's see. Okay, so we have got a transaction and we've got this hello, it's returned hello. So this is on the Etherscan, this is the contract, and these are the operations performed which are being updated here. So this is how we can deploy and run the transaction and run the function, the contract. So this was it. Of course we would be discussing about more advanced contracts, but this was just like a beginner guide and the first smart contract for you guys to build upon. So that's it guys from me.